No? Okay, now you can, I bet. All right, let's see if we get this thing going here. So first of all, I just want to say thank you to the organizers for putting this on, because we are hugely lucky to be able to come to such an awesome city like Barcelona, have a conference like this, spend a few days out here enjoying the nice temperatures. So please, thank you. Give a round of applause for the organizers real quick. The second thing I'd like to do is we just had a big lunch, so I want everybody just to take a second and just breathe deeply. This is actually more for me. The reason being is because I have no idea what I'm talking about. No, just kidding. The reason being is because I'm going to talk about protocols today. And protocols are interesting because the ones I'm going to be speaking about, some of them have been around for quite a while. So there's a good chance there's at least one other person in this room that knows a lot more than I do about any particular protocol. So that's cool. Like, I'm very happy for your vast knowledge in a particular protocol. Mine happens to be DNS. Yours might be anything else. Don't try to quiz me on protocol questions at the end, because a lot of it's just going to go right past my head. What I want to encourage all of you to do, though, is to think about protocols as something that it's a tool that you can use to improve your system. So let's get started here. So what are protocols? Protocols are basically a set of procedures to be followed when communicating. Right? This is really simple. It's essentially the rules that say, hey, when you're talking to me, this is how we're going to communicate. In certain languages, I believe Spanish as well, you have formal versions of pronouns and informal versions. Those essentially are sort of like little protocols. They dictate the rules as to how you're going to communicate with the people around you. So the protocols I'm talking about are technical protocols, but it's essentially the same thing. Of course you're going to shut off on me right now. I bet the batteries just died on this thing. All right, well, let's move it in over here then and control it manually, because that's how I roll. Now it comes back on. Oh, you're an evil little bastard, aren't you? All right, HTTP. Everybody loves HTTP. I love HTTP. I use HTTP all the time. Hypertext Transfer Protocol. Started out in RFC. So RFC is a request for comments. This is kind of the way that the internet, for a long time, the people that have developed a lot of the protocols and the formal things about the internet have communicated with others around them. They're not really standards per se. There's no standards body that sits over them, but they become established standards. So the first RFC for HTTP, the first official one, was for 1.0. Came out in 1996, and it's RFC 1945. It defines all of how you're going to basically communicate in HTTP. And so HTTP is an application-level protocol. So this is actually taken from the RFC as the reason. So Hypertext Transfer Protocol is an application-level protocol with the lightness and speed necessary for distributive, collaborative, hypermedia information systems. That's awesome, all right? We don't always build those, though. So that's why we need other protocols, all right? So I love HTTP, big fan of it, fantastic protocol. It's ubiquitous, it's everywhere. I mean, the one thing you can always count on is that port 80 is open on outbound firewalls. It's like a guarantee, and you can, the cool thing is it's simple, and you can actually tunnel stuff over it. So you have tunnels, you have gateways, you can push things through, you have proxies. I mean, it's very flexible as well. That's really cool. The protocol was designed to not just be one end-to-end protocol, but actually to put things in the middle to transform messages along the way, filter and things like that. That's awesome. But there is life beyond HTTP, and today that's what I want to talk to you about. I want to show you what some of the options are out there. And by the way, you probably are going to know most or all of these protocols at some level. Hopefully, when I give you the demos a little bit later, I'm actually going to get into some code, and I'll show you how you can talk some of these protocols with Ruby. There's libraries out there for all kinds of protocols, really neat stuff. So let's meet some new friends. Oh, SMTP, let's start there. Everybody's probably heard of this protocol. It actually predates HTTP by quite a bit. It's the simple mail transport protocol. Every time you send one of those fantastic emails with a picture of cats attached to it, because I know you all do it, this is the protocol that it uses to go over to the people that everyone in your list that has to see the fantastic cat picture. The original RFC that came out was 788. It was in 1981. So John Postel actually said, he set forth what this is going to be. It's been obsoleted by RFC 822, which is what everybody really knows as sort of being the SMTP protocol. So it's been around for a while. I mean, think about that for a second. 81, 2000, 31 years. That's a long time for a protocol to live. Fun little fact, don't know if you got, mail used to depend on FTP. All right? People would say, if I wanted to send you mail, I would drop it onto an FTP server that you would then come and get it off of. That's how mail, there's actually some information about there. Go look it up sometime, FTP mail. It's really cool. So this is kind of what a session looks like. It's going to be a little small, but you're going to get the idea. It's plain text, all right? So essentially, we've got a bunch of codes up here. I bet there's a laser on here, but screw it, I'm not going to go for it. So we have this, you connect to it, and you say, hey, the first thing you do is it connects to the server, and the server says, yo, I'm talking ESMTP, which is the extended SMTP protocol. The client goes, hello, I am this, or hello, you know, whatever. So, and then he says, okay, hello, glad to meet you. It actually does this type of stuff. This is an actual printout of what it might look like. And it says, okay, hey, I want to send mail from this to this person and also to this person, and now I'm going to send you some data. And the server goes, hey, cool, send me some data. Finish it with a carriage return line feed dot carriage return line feed. And the client goes, okay. And he says, okay, well, here's the message body. Num, 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 sends the text over there. And at the end, he gives the dot, and he says, okay, I queued this up as this. And the client just unceremoniously goes, fine, quit. And the server's like, bye. So that's really cool. That's the protocol right there. Now, obviously, there's a lot more to this protocol, but it's based on this simple idea that you can talk with plain text. So that's kind of cool, right? SMTP is all over the place. I'm sure all of you have used it. A lot of you probably actually know your way around it, given that most of us are Ruby developers. We build web apps. Most web apps actually send at least one email somewhere. So you probably know your way around a little bit. So first protocol, SMTP. Second one, DNS. DNS. I love DNS. This is the protocol that I'm in love with. It's terrible. DNS stands for Domain Name System. Its first official RFC, really like the one that everybody points to, is 1034 and 1035, one of which sort of says, hey, this is what the domain system is. And the next one says, hey, this is what the domain system protocol kind of looks like. And then there's many, 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 many more RFCs along the way that have added on to it. One of the things you'll learn about protocols that's really cool is that they tend to be extensible. A good protocol has a really long life because it's not locked into a simple set of messages that can be traded back and forth. It's just flexible in that way. So DNS is no stranger to flexibility. Fun fact for this one. Before DNS, all computers grabbed their host.txt file from one machine at a company called SRI. So it's like, oh, hey, it's Monday morning. Go grab the host.txt file. That's pretty insane when you think about it. The scale was a little smaller. Now we have hundreds of millions, or I don't even know how many billions of machines attached to the internet. So that wouldn't have worked for too much longer. Can you imagine that every morning you could be going and fetching host.txt from SRI? That would not have worked. So they built the DNS system. So DNS is based on UDP. Well, it's not based on UDP. It typically uses UDP as its protocol. You can use TCP, and in fact, if the packet is larger than 512 bytes, I think. Anyway, if it's a pretty small packet, then it'll switch over to TCP. Anyway, this is the basic form of a packet. This is actually the ASCII art from right inside the RFC. I love it. RFCs with ASCII art are the best. So you can see it's pretty straightforward. You got a header, which says, hey, this is just some basic metadata about this packet. You've got one or more questions, one or more answers, and when the client sends over the questions, the answers are going to be empty because the client doesn't know anything. When the server sends it back, it's going to send all the questions and all the answers back. And then it might also say, I'm not the authority, but here it is. So that's actually when you're delegating to another set of name servers. And there can be additional records as well. I'm not going to go into the details of this right now. All this is available inside the RFC. But I think it's anyway. More ASCII art. So the cool thing about DNS, so it talked about SMTP. It's a text protocol. DNS, on the other hand, is actually packed into binary packets. All right, this is actually really fun and really frustrating at the same time. It's a whole bunch of challenges because most of us nowadays don't think a lot in binary unless we're trying to really make things fast going back and forth, right? Or unless we're dealing with binary data to begin with. But in the case of DNS, it tends to be text data that is packaged into a packet. And this is what a basic resource record format looks like. Okay, I had water here. Okay, who ganked my water here? Did you steal my water? Look at that. No, he didn't. He didn't really steal it. This is a new one. So a basic resource record looks like this. So those are 0 through 15. That's the bits, right? And you've got 2 rows of those bits. So you've got basically 16 bytes. 16 bits. Screw it. I'm always bad at this stuff. It fits into that space. Let's just put it that way. It's bytes, it's bytes, it's bytes. All right, so 16-byte type, 16-byte class. Type is the actual record type. Class is some esoteric thing that we don't ever really use anymore because everybody's on the IN internet class. You've got the time to live. That's how long this record can stay around. which is a 32-bit integer. You've got the length of the question, or yeah, I think so. And then our date, even this, see, this stuff's so arcane, but it's great fun. And then the actual record data. And then the final one that we have, this is the header, what it looks like. This is how you pack the header together. You've got a 16-bit random ID that's going to, when you send out the packet, you're basically going to get packets back at random because UDP doesn't have any guaranteed delivery. You may or may not receive the packet. But when you do, you have the ID that you can match it against to ensure that you're actually sending back the correct, that you got back the correct response. You've got the QR, and by the way, I've got great notes on all this to remind myself. But basically all these, like there's a single bit there. Is this a question or is it a response? That's the QR bit. You got the operation code. You've got, is this the authoritative bit? Is it truncated? All kinds of really cool things. And the counts. So that's the header. I believe this. Anyway, so let's move on. Screw it. I could talk about DNS all day long. But I want to move on to some other protocols. So XMPP, the Extensible Messaging and Presence Protocol. So this is what Google, like Google Talk and Google Chat and all that, not Google Talk, but Google Chat works on, essentially. They built it on top. You might also know by the name Jabber. It's kind of cool. It's basically it's very, very, they've added a lot to it since the last time I looked. As I was reading up, preparing for this talk, I was looking at all the various extensions, and it is truly extensible. The only downside is that it does this extensibility with XML. But, you know, if you want big fat messages, that works, and apparently it works pretty well. So this one is actually specified by a series of RFCs, 3920. You can see 2004, we're getting, these are newer. These are relatively new RFCs here. Not even 10 years old yet, little kids. I've left out examples to like save you and not hurt you with the XML. If you go look through the spec, they'll show you how the messages all go back and forth, how you define presence. I mean, it's not elegant, but it works really well. And so that's the XMPP protocol. IRC. Yeah, IRC is actually a pretty cool protocol as well. So IRC is for multi-person chat, essentially, right? Internet relay chat, and there's an RFC for it, 1459 in 1993. So this one's got some age on it. It's not just for script kiddies, that's all I'm saying. So a lot of things you can do with the protocol, but I'll go into some details. I don't know, since we don't have an internet connection, unfortunately, I can't really show you. I'm not running my own IRC server locally. But what I'll do is I'll push up my repo with all of my examples, even ones that I'm not going to show you today, onto GitHub later when I do have a network connection, and you can go take a look. It's all really simple stuff, and there are libraries for all of this, so I'll talk about in just a bit. SSH, Secure Shell. So another protocol. Secure Shell, everybody uses it all the time. Secure Shell lets you talk to a remote machine with encrypted, basically encrypts the data going back and forth. That way people don't go in and log in as you and do bad stuff. That's the theory behind it, right? SSH has been around for quite some time, but the actual RFCs for it are relatively new as well. 4250 through 4256 are the reference RFCs. Fun fact, I like these here. The original announcement on a mailing list included the following. Putting this openly available for FTP in the US may make you eligible for charges on ITAR violations with penalties up to 10 years in prison. America? Fuck yeah, that's right. Has anybody ever been put in prison for putting SSH up on FTP? I don't think so. Thank God for that. But the bottom line is that there was strong encryption in this stuff from the very beginning. And it all originated when somebody at a university, they basically got attacked. And he's like, well, this sucks because we only have Telnet, so I'm going to come up with this new thing, SSH, announce it on the mailing list, so on and so forth. So, moving right along, taking you through a quick whirlwind tour of various protocols. Stomp. Stomp is really, you know what, screw the how many of you. A bunch of you probably use queuing systems in applications that you build. All right, so you might use a centralized message broker. It's fairly common. If you use a centralized message broker, there's a chance that the protocol between the client and the server is Stomp. That's what it is. Stomp is a streaming text-oriented messaging protocol. It's also a great musical. No, just kidding. So essentially what it does is it lets us say, I want to post this message up somewhere, and then I want to either have another subscriber pick it off, or I might want to fan out and broadcast and have a bunch of subscribers pick it off in a topic queue, right? RFCs, RFCs are for kids on this one. There's no RFCs for this. There's a spec that's essentially on GitHub that you can see. So when the communication looks kind of like this is a little what it might look like. So the client connects to it and says, hey, this is the version that I want. This is the host that I'm connecting to. It kind of looks a lot like HTTP. And in fact, that's what it's based off of. It's the same. I'm going to have a connection, like basically a verb, if you will. And then I'm going to have headers, which is the metadata about the message that I'm about to send you. I have a break, and then I have the message itself. And it's terminated by a null character. Is that me making that freaky noise? Sorry about that. I'm not doing it on purpose. So we connect. The server comes back and says, hey, you're connected. Yes, I support 1.1. Then I send over to a destination queue a particular message of a content type. So you might, in this particular case, text plain just, hey, hello QA. But it could be JSON, it could be XML, it could be whatever. It could be HTML for that matter. Now on the client side, so you do that and then you disconnect. So that might be what the client session looks like. Another client who actually is going to listen for things is going to say, hey, I want to subscribe. All right, here's the my ID. So this is basically, or it's going to say, this is the unique ID for me. Let's see here. Oh no, this is the one that came. Yeah. So this is I've truncated here. My bad packets were too large. Anyways, so this is saying, hey, I want to subscribe. The server says, okay, cool. This is the destination. We're going to come back, and I'm going to have the act client feature. And then I send it. And then this sends. It says, here's a message that I have for subscription 0, and it says this is where it came from. And there's the message, hello QA, terminated by a null character. So basically, it's just a way to have message queuing back and forth. A lot of open source projects that like Apache's message queue, message broker supports this. There's various other ones as well. Disconnects, yeah, all kinds of things. All right, so last one that I'm going to talk about, and then I'll switch over to my quick demo of stuff, of what I can show you. Speedy. So Speedy was conceived over at Google as sort of the next generation of how we can do HTTP. So it's a layer that's kind of, it works in conjunction with it. It uses HTTP internally, but it adds a frame layer to it, essentially, so that you can multiplex. The idea being that in HTTP, you send one message and you get one message back. Well, in Speedy, you open a connection and you can interleave messages in parallel all over the place, and you get responses back in parallel. So there's no guarantee, like, they'll just come back in different order, and as long as both the client and the server can handle it, you can get a lot better perceived performance because you can parallelize how you're sending messages back and forth. You don't have to, it doesn't use any of the HTTP keep alive or any of the hacks. It's actually a new protocol that's built straight on top of TCP, essentially. So it's kind of neat. This is where you can find out, again, no RFC for this. This is a long URL. You can go look at it later. But it's essentially for part of the Chromium project, which is the top-level project that, under which like Chrome browser and the Chrome OS stuff lives. You can read the protocol there. It's neat, though, because you can do request prioritization. So you can say, oh, this message from the client is really important, so handle it first, and I might be sending other messages that can be delayed. So that's kind of cool. It also compresses down the headers, because it was determined that a lot of the same headers are being reused back and forth. Well, you don't just... You can reference a previously, like you can say, okay, well, I have this header. I can reference something I've already sent before if it's similar. It also does server push streams, which is really cool because as we move towards web applications or any sort of HTTP application, which requires, where you want to have a client be more interactive. So in the sense of there might be multiple things going on the client screen, and I want to still work inside of the context of a web browser, and I might want to execute some messages and update state. Like let's say there's offline state that's being updated on the server and I want to push that down. The protocol has that built into it. So that's advantageous if you're building that type of apps. It's the same type of stuff you might do with WebSockets today. Instead of having to have a separate protocol, it actually just sits on top, everything sits on top of Speedy. So it's a neat protocol. So application protocols are cool, but what about transport protocols? Let's take one layer down now, all right? So we were just up at layer 7 in like the 7-layer stack, giant sandwich, right? We were at the juicy bacon part. Now we're moving down to more to the lettuce. Like this is the stuff that makes it move. This is the fiber provider. So TCP, you can quote me on that. Transmission control protocol, essentially it's a reliable protocol that lets you have an ordered stream of octets. And it basically says, if you actually want to get this thing, I guarantee I will get it to you. It might take me a couple of retries. It might take me a little longer, but there's guaranteed delivery of packets back and forth. So that's really important, especially for things like HTTP, where, although what's interesting is that in the HTTP spec, It actually says HTTP can be used on top of other protocols like UDP. And in fact, it is. Universal plug and play, which is really cool. I was reading about this. It sends, basically does HTTP over UDP. I didn't know this, but it's really cool. Anyway, UDP is kind of interesting for discovery mechanism. It's like, hey, world, I'm going to multicast out. Somebody come back and tell me what you can do. Well, apparently they've implemented HTTP on top of UDP for that. Really cool. Speaking of UDP, oh yeah, this thing's starting to get annoying. The user datagram protocol. So essentially this protocol says, I'm going to stick my data in a very little datagram, and I'm just going to send that out. All right? And I'm going to send it to a point. We don't have to establish any connection in advance, essentially. Like there's no connection that says, hey, I'm here, yes, you are. There's none of that. It's just be like, hey, server, here, take this packet. No, take this packet, like this. And the server's going, okay, I'm just going to start responding to stuff. You take this packet back. And that's it. That's how it kind of works, right? Pretty neat. Used for things like DNS and a bunch of other things. No guaranteed delivery, no ordering, and no duplicate protection. So the server might go, take this, and take it again, and take it again, and take it again. And you, as your application layer, has to figure it out. All right? So in things like DNS, the tools, the resolvers, or the clients, or the authoritative servers figure it out and make sure that the packets get ordered properly and sent. And they use those IDs. If you guys remember back to that ID field, that's used to make sure that you route that to the correct handler, essentially, that's going to respond to that DNS request. It's neat because it avoids the overhead of actually having to have the transport layer figure that stuff out for you. And with that, let's move to the code. Hold up. So this is going to be a lot of fun here. So first thing I'm going to do is I'm going to see if I can write TCP dump. Let's see here. There we go. So there's a tool called TCP dump, which is pretty neat. And right now what I've done is I've set up a little shell script that adds a little configuration TCP dump, and I'm saying, hey, TCP dump, only listen to, and let me show you that shell script here real quick for a second. Again, I'll put all this up. So this is that little shell script there. And it's like TCP dump, I want very verbose output. There's a couple other flags in there that essentially say I want to see ASCII output and things like that. I want to listen on a particular interface. I'm listening on the local interface. And I want to listen to only stuff on port 1025. And they have to be of type TCP. And I want these particular TCP flags, which are push. So the way TCP essentially works is there's SYN, ACK, push, urgent. There's a couple different flags so that the network can essentially figure out what to do with those packets. Or the network, the device, essentially, can figure out what to do. So now I'm running that. And what I've done is I've set up a little script over here called smtp.rb. Let's take a look at that real quick. All right, so this is the first bit of code. So this uses a great library called Mail. All right, Mail is inspired by Tmail, which was originally in from a while back in the Mail. But this one's really good. It's a simple protocol, has a nice little DSL, right, for it. And it's like, okay, hey, create this. I want to have a message from this to this subject. So it's the same. Those are the headers. Essentially, it's going to set up. It's also going to help with the routing. I tell it I want to deliver via SMTP. Here's the address. Here's the port. And then I deliver it. All right? So this is like just saying, hey, send this SMTP message. I run that here. And there go your packets by on the right. All right? What's interesting is we can actually look here, back up at the top. And you can start to see things like this here. So that's saying, hey, the SMTP server I'm using is the Event Machine SMTP server. What I've done is I've set up a little thing called Mail Catcher that will actually catch that mail locally. You can actually see those messages going back and forth at the tail end. You also get a bunch of taking time. Like, I don't know if anybody saw my tweet last night, because I know you all follow me on Twitter, especially you guys over here. That tweet was like, I was seriously reading through TCP dump explanations at 12:30 a.m. because I was like, oh my God, this is insanely complicated. But it's not really once you get to use it. The important thing, though, is we can actually see what's going back and forth. There's the nice little hello, extended hello, and saying, here's who I am. And the server says, OK. And it says, here's the maximum size I can take, and no soliciting, of course. And then it basically says, here's where the mail's from. And the server says, OK. Here's who you're sending it to. The server says, OK. And here I'm sending data. And the server goes, yo, send it. And then that's it. And then it's like, OK, here's the headers. So all those are individual TCP push packets that are being sent across. I filtered out all the SYN and ACK, all the stuff that makes the guaranteed TCP delivery stuff actually work. just so that we could focus on that. So that's one example of one protocol. That's SMTP, right? Pretty straightforward. All right, let's take a look at something else here. Let's run the DNS one. All right, so I've done this. I've set up a little DNS server here. This happens to be a little DNS server that I'm working on in Erlang, so this is kind of fun times. So the DNS script, this uses a library called NetDNS. NetDNS is pretty cool because it lets, it's a really nice way to communicate with DNS from within Ruby. It's pretty straightforward. Essentially you say, hey, here's the resolver. I can configure it with timeout levels, things like that. And then I just say, hey, I want to query a particular name and type. All right, so in this case, I'm looking for an A record type. That's this part right here. And the name is whatever I split that in. The only reason I did this is because I was going to try a bunch of other queries if we had a bunch of extra time, but I don't. Then I'm going to print out the packet, and then I want to just print out the packet header format. Just kind of cool to see that. So I'm running that here. On the left, you'll see that's where the output's going to come. So there it went. This is essentially a formatted version. You can see all the different, the QR, opcode, AA. Those are all those different flags I talked about in the header. This is the question section. Because it's the response, it comments it out, saying like, hey, you don't need to process this because I've already done it. And then it gives you back the answer. And this is just running locally, so it's just a bogus IP address, 1234. And then that's the header packet in the same ASCII art format that you saw on the RFC. So that's kind of cool. So with that, you can actually do some really powerful things with NetDNS. You can resolve all types of records. Like it's really fantastic. So if you need to do any DNS stuff, you can look at that. The only thing is it's going to do synchronous DNS lookups, and asynchronous DNS lookups are all the hotness these days. So you can't do that yet, but anyways, pretty cool stuff. Now notice this one. I'm running some Java here. I'm running Apache Apollo. This is going to show you Stomp. All right. So this is the last demo I'm going to give here. So let's take a look here. What do I have in this directory? I can actually get rid of this now. Take a look at this. So I've got well, I should. Okay, that's kind of messed up. There, Stomp Publisher. You see it. Where is it? That's very odd. Okay, so I have a Stomp Publisher, and I did at least before. Yeah, it's still there. And I have a Stomp Subscriber. So the publisher is going to put messages into the queue. All right. And this is the code. It's using a thing called OnStomp. There's a couple different libraries. And it's basically just going to put a message into the queue. And while it's running, it's going to say every 5 seconds, it's going to dump a text message into the queue. And on the other side, we have a subscriber over here that is going to connect. And every time it gets a message, it's going to print that message out. And it's just going to do that for all eternity. So I'm going to start the subscriber first. All right, that's running now over here. And where am I? There we go. And here I'm going to start the publisher. And yes, indeed, it's sending messages. And under the hood, it's sending those text messages back and forth. So those are some examples of some of the protocols. Pretty much for every protocol I mentioned and a whole bunch that I didn't, there are libraries out there in Ruby land that you can do this. There's libraries in all kinds of languages, but really it's extensive, the amount of libraries that are out there that you can use for these various protocols. So I suggest you take a look at it at another time at your own leisure. And with that, I'm going to finish up. Protocols are awesome. Okay, protocol, like APIs are here. Protocols are here. They're one level of awesomeness above APIs. So I highly suggest that you know them, not through and through, but you know that they're out there. You use them and you learn to love them because they can help you build systems that are going to interoperate with other systems in completely different languages very, very effectively. So get to know them. And before we go over the questions, I'm going to give you 3 questions before you guys have a chance to give me any questions. My 3 questions for you are this, all right? These are things for you to think about as you leave today or tomorrow, whenever you're done with the conference, and to think about as you go back home. So what APIs do you use right now that might be better implemented as a protocol? I can think of one straight off the top of my head, Twitter. So there are others out there, though. So think about that a little bit and think about it in the ones that you use in your companies and in your projects. Like when you look at it, you're like, man, this thing should really be a protocol so that it has a longer life and so that it's not as tied to like these breaking changes, right? And controlled by one entity. What are the characteristics? Ask yourself this. What are the characteristics of a protocol that doesn't just die off? Because there's a bunch of protocols you'll never hear of. because they never got adoption. So it's interesting to figure out what is it that makes them have long lives. And the final question is, what APIs have you written that might actually make a really good protocol? So think about that. Thank you, Baruco. And that's it. So,
okay, are there any questions?
if you have questions, like I said, I'm not a big, if you ask me random questions about specific protocols, you're not going to like the answers. But I'm open to other questions if you have any.
Hi there. You had a question about IPAs, IPAs? Something on my mind. APIs.
I agree with you.
Yeah, APIs that graduated to becoming protocols. Can you think? Are there any examples that that have actually kind of made that jump? Because I can't think of any off the top of my head.
Well, actually, messaging I think is a very good example. So messaging, there were a bunch of proprietary messaging protocols, and everybody's like, "Wow, there's a bunch of proprietary messaging protocols." Not really protocols. Actually, they weren't even open, right? They were all hidden, and everybody had their own proprietary one they weren't sharing. And somebody came along and said, "Hey, you know, we need an open protocol for this because everybody does IM, and this really sucks to have 17 IM clients open." And thus was born XMPP. It may have actually even come before that. But the point is that XMPP represents an example of sort of a standardization of an API that then moved into a protocol. Whether it's the right one is another question altogether.
Thank you.
You're welcome. There's a question back there. Oh, hell. These are coming. Oh, Randall's going to ask while you wait. So you're on hold for 1 second. Randall's going to ask up here a question. So just 1 second. Go ahead, Randall.
So you were mentioning about protocols that actually have a long life. What are your thoughts on some of the facts that a lot of protocols don't evolve, like, you know, for instance, DNS?
Wait a minute. So are you suggesting DNS hasn't evolved? Do I really need to point you to DNSSEC? Really? Really? No, actually, DNS as a protocol has evolved greatly because if you recall, originally the packets, the specs were like, everything's got to fit into 512 bytes. It's like, that's the rule, except when it isn't. And the only exception they made in the very beginning was essentially for transferring the entire zone transfers, right? It's like, okay, we're doing zone transfers. Yeah, we can't fit a zone into this many bytes, so we'll provide a way to fall back. Since then, they've added an additional flag into the protocol called, what is it, E0, I can't remember exactly, but the flag essentially indicates that we are now going to extend beyond 512. It tells you, there's also like a size that says this is the new size max. And then in addition, it's got a couple other flags that essentially can be used to indicate, is this going to be DNSSEC and things like that. So all this is designed to support DNSSEC. That's the goal. So the DNS protocol actually has evolved. Just go look at all the different RFCs. Granted, it's evolved in a way where mostly we've added new record types, and record types have died off. But it actually continues to evolve even today, except for the whole CNAME on the root zone thing. But I'm not going to get into that. So your question back there.
Yeah, great talk. Thank you. Really enjoyed it. Just the thing about the SMTP protocol, you said that we should love protocols, while like SMTP is super slow, verbose. I mean, that's like DNS. It's really like a protocol that it would be great to see like evolving, because whenever you build a web app, like sending email is basically the thing that you're sending nothing, and it takes like forever to send an email.
So it's interesting. I'm going to put these two together here right now and put it into one concept. I think what you're looking through is not evolution. You're actually looking for a revolution. You're looking for a new protocol to replace this existing protocol, because the fact of the matter is that they have been evolving really slowly. SMTP has evolved very slowly. It continues to evolve today. But things like that are dramatic. And that's when you have things like Speedy is a great example of somebody coming and saying, we have this really long-lived protocol that we have to work with, but we're going to try to sort of revolutionize it a little bit by we're not going to build on top of it, we're going to build next to it, on top of TCP directly. There are opportunities to do it, for sure. And SMTP may be one of those protocols, so that's cool. All right, I want to keep things moving forward. So I'm not going to take any more questions right now. I'm starting to get scared anyways. What questions are going to come next? I hope all of you are at the drink up tonight at the beach party, and you can ask me all kinds of questions there. So thank you very much. Appreciate it.